When temperatures get this cold, sometimes your car can struggle to start. But why? Jeff Smith is with Imagination Station's chief scientist, Carl Nelson, to explain the science that happens the moment you turn the key.
So we are trying to think up at the station, how many different ways can we explain exactly what's happening this weekend with the cold? And we thought, well, the cold always affects our cars, getting ready in the morning, especially if it sits out. So once again, Chief Scientist Carl Nelson with Imagination Station, nice enough to spend some time with us to kind of talk us through that when you feel your battery doing that terrible impression. But when you hear that, what's actually happening in these cold conditions?
So your battery is a big chemical reaction, basically. And when cold temperatures come, those chemical reactions slow down. And it just becomes harder and harder for the battery to produce enough current to turn over your starter motor. Now, some newer cars have warmers or heaters on the batteries, right, to warm them up. But if you don't have that, sometimes it can be really difficult to get your car started. So I thought we would do a chemical reaction here with two different kinds of reactants. One that's very cold, and one that's warm. Okay? So this is called elephant's toothpaste. That chemical is hydrogen peroxide. Okay? And what we're going to do is I'm going to have you add a little, add some food coloring first.
To the water?
To the hydrogen
peroxide.
peroxide.
To the hydrogen peroxide?
So I'm going to dump the whole thing in.
Okay.
Just dump the whole thing. We're going to make a mess. So you've got blue for the cold solution. I have red for the hot solution.
Makes sense.
Okay? And then the next thing we're going to do is we're going to break down the hydrogen peroxide into oxygen gas and water.
And this is supposed to mimic what?
Well, this is a very slow reaction. This is a very fast reaction. And the only difference is the temperature. All the components are the same. Same amounts, same components. Other than the food coloring being different colors, we're going to see what happens. Now, if we add our catalyst, which will start the reaction, all the oxygen will come out of that solution, it'll make a gas, and we won't see anything. That's not going to help us. What we need to do is capture that gas in a foam. And so that's why you have some Dawn detergent here. Go ahead and dump your Dawn detergent in, and that is going to be the substance that helps us see the amount of gas that comes off. And again, we're just trying to make an analogy with your car battery if you have a cold chemical reaction or a hot chemical reaction. So I'm going to give you this. Go ahead and open that up.
All right.
And we'll do these one at a time so we can kind of compare them. Go ahead and take the cap off and then just dump that in. That's potassium iodide. That's our catalyst. And just dump it all in really fast. Okay. Now, as you can see, it begins to kind of slowly creep up. We're moving up. And that's a slow chemical reaction compared to, let it go there for a second so we can see. It's really kind of mesmerizing how big it gets.
And the steam, what are we seeing there?
Well, it's an exothermic reaction, so actually giving off heat. Okay. Watch what happens though if we do the reaction with the warm reactant. We'll dump this in.
Whoa!
Yeah, you want to step back a little bit?
Yeah.
You can see that popped out in a couple seconds.
Right.
And that is what's happening when your car battery is warm. It can supply that current, the voltage, and get your starter motor going very quickly, whereas yours kind of lumbered out, and it took quite some time for that reaction.
Once again, my bad impression of
yes.
right?
Yeah. So yeah, this chemical reaction has nothing to do with car batteries, but it's the concept of a cold reaction going slower and a hot reactant allowing the reaction to happen faster.
Gotcha.